Hi, I'm Randall Heyman, a mathematics academic. A lot of people, unfortunately, are affected very badly by the coronavirus outbreak, so I'm using my YouTube channel to help university educators, teachers, parents and students with any mathematical problems or concepts that they're having trouble with. If you'd like me to make a video for you or your students, just use the comment section below the video. So we're currently heading towards what I've got up here. Understanding of these things for a class in California. We've talked about groups. Now I want to talk directly about rings, which is involved in this third one here, third one of the list. Okay, so in order to motivate rings a little bit, I've talked in groups a lot about integers, but as we know with integers, there are two major operations, addition and multiplication. So a ring is something that encompasses two operations. So let's just write a definition up and that will help us. A ring, so we're going to represent it like this. R is the ring, so that's just a set. So that might be the integers, but it could be a finite set, whatever. And we're going to write two operations. Is a set R with two binary operations. So there are the two operations. Actually, just to be a little bit clearer, let's just write and, not. And I'll just write here, which we call addition and multiplication. So I haven't had time, I don't think, in the videos so far to really explore the idea that we can actually have situations, we can have groups, for example, rings, that do not, where these operations are not addition and multiplication. In fact, I think in my video on groups, I give an example where the operation, the single operation that you need for groups is actually a combination of addition and multiplication. But just generally, we'll talk about it as addition and multiplication. So we've got a few things that we need. The first is that if we consider just the set with the operation addition, well, that has to be a group, but it has to be an abelian group, which I talked about in the previous video. So that just means that you can change the order at which you apply this operation. The next thing is that we need is that multiplication, which is that I'm calling it multiplication, it's just that second operation, has to be associative. So we saw this in groups as well. So what do I mean by that? That is A times B. So A times B times C must equal A times B times C. And we must have left and right. Left and right. Distributivity. So this is the distributive law. Distributivity. So what that means is that if we go A plus B times C, that must be the same as A times C plus B times C. And also we can do it the other way as well. So A times B plus C must equal AB, A times B, I put a dot there, plus AC. So that's left and right distributivity. Now, here's one of these awful problems in mathematics where there's vagueness about what a ring includes and doesn't include. So in some cases, people will insist on an identity element for multiplication. I.e., you know, in the case of the integers, there's this special number 1, 7 times 1 equals 7, that leaves the number, whatever number you put there, here, any integer times 1 is the same integer. So in the book that I'm using here, they don't assume identity. If they want identity included, they'll say a ring with identity. But in other cases, people will specifically include the identity element for multiplication in the definition of rings. So fortunately, it's one of those things you've got to get a sense of just from the problem that you're looking at. So also just keep in mind what I said before. So these are not strictly in the definition, but just important things. Just remember what I said in the last video about closure under multiplication, that it's implied from multiplication, because y, i.e. addition, is actually the process of taking two elements of the ring and mapping it onto the ring. So if I defined whatever this, sorry, that should be multiplication. If I define multiplication properly, whatever multiplication is in the sense of this ring, well, then I would give you this setup, and so closure is assumed. Okay, so that's been quite a bit. So let's stop there. I'll give you some examples of rings in the next video.